Okay, this is the last section in the chapter. Hopefully things are going relatively quickly. We had planned for about 8 hours. I circled the ones I think you should do. 1, 2, 3, 5, 7, 9, 11, 12, 14. I was trying to give you a couple from each section. You can always do all of them. Do as much or as little as you like. These are matching, so what the heck, just do them all. We'll probably end up doing a couple anyway. And then 2 word problems. Do 21 or 22. If you want to do both, go ahead and do both of them. So I'm going to try to go back to my... What would it look like if you were just doing this on your paper? So here we go. This is, I kind of forget what the title of this one was. We went over all that at the beginning. Oh, represent functions as graphs. This is represent functions as graphs. So the x-axis of the graph of a function is labeled with the input variable. The y-axis of the graph of a function is labeled with the output variable. Or horizontal and vertical. I like to tell people there is no such thing. Maybe I should zoom out a little. There is no such thing as x and y. So this is 1.7, and number 1 would be the horizontal or x-axis is labeled with the inputs. And the vertical or y is labeled with the outputs. They wanted the ordered pairs, so I'm going to copy this table. Inputs and outputs, so we can call them x and y since we don't want to record the words input and output. So each of these is a point. So as an ordered pair, I write 3, 2, 6, 2, 9, 2, and 12, 2. And heck, what's going on? Y is always the same value. And sometimes we tend to think of that as a vertical line, but really if y is always the same, it doesn't matter what x is, that's going to be a horizontal line. We'll get to lines later. For now, these are just discrete, individual points. Okay, so that's changing a table into a set of ordered pairs. What's next? Identify the ordered pairs in the graph, then identify the domain and range. So if I were to look at number 8, since I didn't ask you to do that one, this is interesting. Whoops, that's my oven going off. Since this is odd. I think these are not negative numbers, but positive numbers. 8, 6, 4, 2. I think that's making them look negative. But anyway, what do I have here? I have 0, 9. I have 1, 8. I have 2, 7, and 3, 6. So number 8 would look like this. 0, 9, 1, 8, 2, 7, 3, 6. The way this axis is labeled, that we couldn't go from, there's obviously 2 units between 10 and 12, so there's no way I could have gone from 10 to negative 8. Here are clearly some negative values. So if I did number 10, I'd have -3, and this looks like -7. The input goes first, the output comes after. In this case, -2 looks like 2, 4, so that's about negative 3. And then this is negative 1, 1. And this is 0, 5. Oh, so domain is all of my inputs. And again, these are discrete. So my domain is 0, 1, 2, 3. And in this case, my range would be, and I'd still write it in order, 6, 7, 8, 9. They don't have to be corresponding pairs. This tells me the correspondence. When I'm writing the domain and the range, I would list them in an order that makes sense. So down here, my domain would be, well, negative 3 would come first. Negative 3, negative 2, negative 1, 0. And my range would be, whoops, no parentheses, negative 7, negative 3, 1, and 5. Graph the function. So down here, they want me to graph y equals x minus 3 with a domain of 6, 5, 4, 3, and they just prove me wrong by writing it in that order. So 6, 5, 4, 3. I'm going to make a table of values, and I'm going to actually put these in order. And y equals x minus 3. So 3 minus 3 would be 0. 4 minus 3 would be 1, 2, 3. So there's my ordered pairs. I'm going to sketch. You guys should do a little better job of this. This is my x, and this is my y's, and you should indicate 1 and 1, indicate what your units are. So 1, 1, 2, 3, 0, 4, 1, 5, 2, and 6, 3. And I'm not connecting them. These are discrete values. They're giving me the domain. If later on, we'll see what happens when we're not given a specific domain. Okay, that's graph the function. Match. Some of you guys might recognize this idea of slope. There's a slope of 1 in there. This idea of vertical intercept. This graph starts at 0. This graph starts at 0. And for every 1 on the y, for every 6 on the x, I'm going 1 on the y. So let's see. Who would 16 match up with? I'm going up 6 each time. So that might look like this one. And I would have started, I guess I would look for a solution. What is this? 1, 5? These are kind of hard to look at. This one has a pretty shallow slope. I'm guessing that's this one. 1/6. 2, 8. Nope. That's this one. 8 minus 6. 3, 9. That's this one. 9 minus 6 is 3. 1/6 x. Well, I guess I should look at the scale. So, like here's a 24. 24 divided by 6 is 4. That's that one. 18 divided by 6 is 3. That's that one. So this one would be C. Anyway, plug in and test and see points. See how that works. And then finally down here, they're giving you some values and you just have to plot them. So 1 hour is 675. So you kind of have to estimate 1 and 675. And I sort of like that because sometimes we just want a general picture. We don't have to be so specific. And at 2, we'd have to go to 1350. That'd be somewhere in here. And again, these are going to be discrete points. So you just want to graph them discretely. We're not connecting anything. So I think you can handle that one. And once you've finished this and checked this, it's time to check yourself on the assessment. So when you get back, you'll be taking a test. So go through the Chapter 1 practice test and check your answers to that. And then when you come back to school, you can ask any questions that are still out there.